Hello there, year 8s, Mr. Herman here, and this will be the lesson Conduct Chance Experiments, which is the essential assessment skill. Learning goals for this one is to look into what a chance experiment is, to also know the difference between theoretical probability and experimental probability. The success criteria for this one is to be able to conduct chance experiments with both small or large numbers of what's called trials, using appropriate digital technologies, i.e. a calculator. So for this one here, I've gone ahead and taken some questions from essential assessment. But before we get into the questions, there's a little bit of theory that we have to look into before we can tackle these questions. There are two main differences between these probabilities. There's what's called a theoretical probability and experimental probability. And while the names of these probabilities might seem a bit daunting and confusing, there's just two main differences. So theoretical probability talks about the chance of an event occurring based on reasoning. Now, reasoning being the key word. So to put it into most simplest form, say for instance you have a coin. You have a coin and there are two sides of this coin. You flip the coin and there is a 50-50 chance or half chance, 50% chance on landing on one or the other, because there are two sides and you always know that the two sides, and you're always going to know that it's going to land most of the time on one of those sides. So there's a 50% chance on landing on head or tails. Now, what happens if you keep flipping this coin about 100 times, and then every single one of them would land a tail? And you would think, there's something fishy about this coin. And you go to flip it again, the 101th time, and you ask yourself, what am I going to get, a head or a tail? Now, theoretically, you should have a 50-50% chance. It doesn't matter because you know there are two sides. Even though you know that it's landed on tail 100 times and you think something's up, theoretically speaking, you should have a 50-50 chance. So it's the number of outcomes for the event, in this case 1, over the total number of possible outcomes, which in this case is 2. It's the same with a dice, a 6-sided normal plain dice, and you want to know what the likelihood of it landing on the number 1. In this case, there is a 1 in 6 chance of it landing on the number 1. And you roll this 100 times, and you get the number 5 every single time. And so the next roll, you say, well, what's the likelihood of this occurring, getting a number 1? Theoretically, it's still a 1 in 6 chance, because you know there is one number of outcomes for the event 1 divided by the total number of possible outcomes. Now, the difference between theoretical and experimental is that experimental probability, the chance of an event occurs based on an observation that you have made prior to that, an observation. So it's different to reasoning. And so let's say that you did 6 trials of some sort where you flipped a coin. There's 6 trials, and you got tail, 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 and only 1 heads. And then you said, okay, what's the probability that my next flip is going to be a tail based on experimental probability? Well, in this case, this will be a 5 in 6 chance. This will be a 5 in 6 chance because you're relying on the experiment to dictate what your probability is going to be. Theoretically, it would just be a 1 in 2 chance, like we said before. But based on this experiment, this trial, you observe that there are 5 tails. And so you say, well, no, hang on, based on experiment, I think there's a 5 in 6 chance and I'll get a tail, which is a higher chance or higher probability than just a 1 over 2. So the probability of this event is the number of observed outcomes, in this case there are 5, divided by the total number of trials. We trialed this 6 times, and of those 6, 5 of them were tails. And this is just a made-up hypothetical example, but I wanted to show you the main difference between theoretical and experimental probability. And we're going to use these two formulas to help us out with the different types of questions. Now, there is one other thing that you should also note that when looking at theoretical probability, the number of outcomes for an event divided by total number of possible outcomes, we're going to use this formula, and we're also going to multiply it by a certain number, but I'll show you this within the next question. Okay, so the first one here, a coin was tossed 10 times, landing on heads 8 times. So we got, here we have heads 8 times, and I'll just put a H there just to make it clear for you guys. And then obviously the other 2 times was tails. So based on theoretical probability, which would be closest, and closest being keyword, closest to the expected results if the coin was tossed a further 90 times? So how many times has it been flipped? So we've started with 10, and we've done this a further 90 times. So 10 plus 90, all up, we've done 100 flips. Okay, 100 flips. Now, theoretically speaking, because half of them will be a head and half of them will be a tail, I'm expecting 50 to be heads and 50 to be tails, because half will be heads and half will be tails, based on theoretical probability. We're not relying on this experiment for now. Just theoretically speaking, I'm expecting 50 heads and 50 tails. So the closest for this, it's not going to show 50 heads or 50 tails, but the closest for this is this one here, which is 55 heads and 45 tails. So that will be your solution here. So remember, this is based on theoretical probability. Let's have a look at the next question. Question 3. The spinner was used 8 times, landing on pink 4 times. Based on theoretical probability, if the spinner was used a further 90 times, which would be closest to the expected results? So this one here, this one's a little bit tricky because we don't have this nice number afterwards that we're going to use. Let's have a look out. The spinner was used 8 times and then a further 90 times. So all up, we have 98 spins. We have 98 spins. And this is where you're going to need your calculator to work out the next part. Based on theoretical probability, so theoretically speaking, what would you expect the results to be pink? So, because all these answers here are pinks. Now let's see, how many wedges are there all up? So the 1, 2, 3, 4, 5, 6, 7, 8. And of those 8, how many are pink? 1, 2, 3, 4, 5, 6. So there is a 6 in 8 chance that you'll land on pink, which is a high likelihood. Remember, this simplifies to 3/4 or 75% of them. So 3/4. Now what you do with this 98 and 3/4 is that from the 98 spins, you're expecting 3/4 of those spins, theoretically speaking, to be pink, and then the others will be either orange or blue. So you're finding 3/4 of 98. And to put this in the calculator, it's just 3/4 times 98. So if I grab our calculator out, we'll put our fraction in, we'll put 3/4, we'll multiply this by 98, and press our SD button. 73.5 or 73.5. So 73.5, which is the closest to 70. So we're expecting 70. We're expecting at least 70 of these, theoretically speaking, to be pink. And we don't care essentially on the experiment itself, because it's not asking for experimental probability, it's asking theoretically. So this one here, this is where question 6 will be looking into experimental probability. So we're now relying on this experiment here that's being conducted to make our assumption or expectation of what the next event will be. So a standard die was rolled 6 times with the results shown below. So we have a 4, a 2, a 4, a 4, a 4, and a 4. So there are 5 4s and a 2. Based on experimental probability, what is the probability of landing on the number 4? So in this case, how many trials were there? There were 6. And of those trials, how many of them landed on a 4? 1, 2, 3, 4, 5. So just kind of like in the previous example that I showed you here, where there was a 5 in 6 chance for tails and heads. For this case here, there's a 5 in 6 chance based on the experiment that you will land on the number 4. So maybe the die is weighted of some sort, or there's some type of bias going on with the die, but there's a 5 in 6 chance based on this experiment. Question 8. The spinner was used 10 times with the results shown below. Based on experimental probability, what is the probability of landing on orange? Okay, so this here is theoretical, where theoretically, if we want to get the theoretical probability, we're going to rely on this here. But we are going to be looking into the experiment. We're going to make our judgment based on the experiment or the trial that's just occurred. So we're trying to find the probability of the next one landing on orange. Well, how many spins were conducted? The spinner was used 10 times. And out of those 10 spins, 7 of them were orange, which is equivalent of 70%. So the experimental probability, based on this experiment, I have a 7 in 10 chance of it landing on orange. And that makes sense because it's landing on orange more times. Even though there's only 3 of them, theoretically it will be a 3 in 10 chance of landing on orange. Based on experiment, it's 7 out of 10. So maybe this spinner is biased and it just is attracted to the orange. Maybe there's magnets involved. It doesn't matter, it doesn't care. We're just basing it on this experiment, so there's a 7 in 10 chance. So we're going to look at 2 more questions, and then you guys can tackle the set skill. This sample of marbles has been selected at random from a box containing 100 marbles all up. Based on this sample, how many green marbles could you expect to find in the entire box? So this is an expectation based on this experiment. So here, this is an experimental probability. So we've taken out 10, and from the 10, there are 1, 2, 3, 4. So there's a 4 in 10 chance, or 40% chance, that you will pick up a green. Now, this is just 10 marbles out of the 100. How many green marbles would you expect within the entire box? So if there's 4 out of 10 within this sample here, I'm gonna just say that 4/10 of 100 is equal to green. So 4/10 of 100 will be green, because if 4 out of 10 were green, then it's safe to say that 4/10 of it, or 40% of the 100, is green. And to work this out, this is just 4/10 times 100. Now, if you're clued in to the maths, you don't necessarily need a calculator. This is just saying that 40 of them will be green. But just to make sure, all you'll need to do is 4/10 multiplied by 100. And this will spit out 40. So the predicted number of green is 40. Now remember, this is just a prediction. We have no idea. We can only rely on the sample of experiment we just conducted. Alright, last question. Before you guys tackle these set questions from the skill. We've got 4 different samples of marbles. They've been selected at random from a box. From these samples, which sample are you most likely to select a red marble? So we've got sample 1, 2, 3, and 4. And so what we're going to do is we're going to look at how many reds were selected from the whole sample within each smaller sample. So here we have 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a 1 in 10 here. There is a 3 in 6 chance here. There is a 1 in 1, 2, 3, 4, 5, 6, 7, 1 in 7, and 1, 2 out of 5. Now, don't look at the fraction itself to determine if the numbers are big or small, because you see, oh, there's a 10 here, so this must be the bigger one, so there's a bigger chance. Not necessarily the case. To make sure you know how to tackle this, you need to convert these into percentages. 3/6 is pretty easy, because this is 50%. The rest, all you need to do is working on the previous skill. If you watched the previous video, 1/10 is 10%. 1/7, so you're going to do 1/7 times 100. This will give me at 14.29, so 14.29%, so close to 14, and 2/5. This is a 40%. So which one of these is the highest percentage to get a red? Which one are you more likely to select a red marble? Well, the 3 and 6 one, the 50%. So even though there are less marbles, proportionally speaking, more of them are dedicated to red. So there's a 3 or 6 or a half chance that you'll get a red from this sample. So this would be your answer here. So to tackle question 16 onwards, you will just need to convert the fractions of whatever the sample you're looking for, or whatever the actual thing that you're looking for. In this case, it's a red marble. Convert these fractions into a percentage by multiplying it by 100, and then seeing which one the highest or the lowest is, depending on what the type of question is. All right, that is the last question that I'll be looking into. You should be fine now with tackling the set questions. You know where I am if you need any help. Best of luck, guys, and I'll see you in the next video.